Morning viewer, welcome to our FTV English version. Here's a breaking news. Viewers, B cell acute lymphoblastic leukemia is the most common form of childhood cancer. In this type of cancer, which affects blood cells, one of the most common abnormalities is the presence of cells with an excess of chromosomes, a condition that leads to chromosomal instability. Now, a study published in Cell Reports reveals that this chromosomal instability caused by hyperdiploidy reduces the proliferations of the affected cells and delays their differentiations and allows some to persist as rare, long-lived clones in the bone marrow, but without triggering leukemia. The study conducted using animal models was led by professors and researchers Oscar Molina and Pablo Mendez from the Faculty of Medicine and Health Sciences of the University of Barcelona and Joseph Carres Leukemia Research Institute. The paper's lead author is Namitha Thampi, also a member of both institutions. The study proposes a two-stage model to explain the origin of childhood B-cell acute lymphoblastic leukemia and initial perinatal stage hyperdiploidy and subsequent post-natal stages triggered by unknown factors, which is necessary to initiate the malignant transformations of rare clones and lead to the development of the disease. Viewers, from the first phase to the second malignant transformation, there may be a time window of between 2 and 6 years, which corresponds to peak incidence of childhood lymphoblastic leukemia. It remains unclear how these rare clones evolved to cause the disease, and understanding this will be key to designing future strategies for the prevention of childhood leukemia. This type of lymphoblastic leukemia can develop when a child's immune system responds excessively to a common infection. So, this response involves the production of large amounts of cytokines and proliferation signals that stimulate the bone marrow cells to divide and produce new immune cells. If the pre-leukemic clone with extra chromosomes is present among this cell, it also receives growth signals and can proliferate more than normal. Increased cell divisions raises the likelihood of further genetic errors. If the clone acquires synergistic mutation, it may eventually develop into leukemia, says Oscar Molina, a member of the UB's Department of Physiological Sciences. Behind this exclusive report, FTV English, Delhi, Bharat.